All right, what's happening first period? I am going to get right in it. I am just here to get your head in the right spot before this group quiz, show you a few key reminders because I won't be able to do it in person. And this is just going to be a 15-minute video packed with helpful hints and reminders. Good luck on this group quiz. I gave the substitute the groups. I already assigned them. You're either going to be in a group of 2 or 3. This is not open note. You can just work together and get after it. But let's talk. Make sure this is recording. I would hate for this not to be recording. Oh man, I got too many tabs open. I know. Yeah, I think it's recording. Is it recording? Sorry about that. It was definitely recording. Okay. So, change each of the following to exponential form. So if you see something on the quiz that looks like this, where it's in logarithm form, log form, right? We need to change it to exponential form. How do we do that? Well, log form, you have a log, you have a little base, you have some number right here, and then you have something out here. The way we change it to exponential form is we start with the base, shoot over to this and become the exponent, and then shoot over to this. So it would become b to the something power equals whatever's there. What does that look like for number 1? 2 to the 6th equals 64. And that is true. But this one over here is a little more disguised, but it's the same way. Natural log has a base of e. So there's always the base of e there. So e to the 1/2 power equals the square root of e. And that's also true. E to the 1/2 equals the square root of e. That is true as well. Okay? So that's changing from logs to exponential form. What if it's in exponential form like 3 and 4 and you got to change it to logs? Well, this is the base. So this becomes the base. The exponent, that -2, becomes your answer. Because remember, logarithms are like exponents, basically. And then this 0.01 is what goes inside the actual log. So, and we can double check. Is 10 to the -2 power 1/100th? It sure is. So that is correct. How do we change this one to log? That's e to the x equals y. It would be log base e, which there's another word for that. It's natural log, but anyways, log base e of y equals x, or natural log of y equals x. Both of these answers are correct. Okay, moving on. Simplifying. If you see simplify, it's probably going to just end up being a number. 3 to the what power is 27. 3 to the what power is 1/9. 25 to the what power is 5. E to the what power is e. E to the what power is 1. And e to the what is e to the 4th. E to the what power is e to the 4th. So that's just 4. But yeah, I think you can figure those out as long as you know how to go around the world. I will do one of them just to help you. So if you see something like number 6 on the quiz, you take the base, which is 3, and you would say 3 to the what power, because there's nothing over there, 3 to the what power equals 1/9. And just a reminder that negative exponents are how you get that reciprocal action like that. So how would we get from 3 to 9? That would be to the 2nd power. So it would be this. But we're not trying to get to 9, we're trying to get to 1/9, so it'd be -2. So your answer would be -2. Okay, so that's the simplifying section. Middle section. There's some of these on there. Change the following to a logarithm of a single quantity. That's where we are condensing. We're going to take this one that has multiple logs or this one that has 3 of them and condense it down into 1. But then over here, where it says expand, that's where we're going to break it out into multiple. So let's do one of these condensing problems. I'll do number 12 because it uses all 3 rules. How do I know it uses all 3 rules? Because I see these numbers in front and I know it's going to be the power rule. The power rule tells us when you have a number in front of a logarithm that's multiplying, it can actually become the exponent. So I'm going to use that rule. I also see a plus sign. And I know that that is going to be the product rule. If you see two logarithms with a plus sign in between them, that can be written as one log with a product where it's multiplied. And then the subtraction here is going to create a division aspect to it. Here's what I mean. First thing we do is we need to move all of those exponents to where they belong. See what I did? That took care of the power rule. Now I'm going to do the product rule with these. 2 logs with a plus turns into 1 log with multiplication. See what that, you can pause the video there and take a look at that. That's the product rule. That's the product rule. And then the quotient rule, which would be, I'll be done after this because we'll be down to just 1 logarithm, is if you see that minus sign, it's going to be division. So z to the third is going to shoot to the bottom. So we'll have 1 logarithm with x squared times y to the fifth over z cubed. Boom. We now have condensed this down to 1 logarithm, right? Okay. The Warriors are playing the Cavs, the Lakers right now, and they are up by 13 at half. So it's not going to be good for me if the Lakers lose. I'm probably glad I'm not coming to school tomorrow because I wouldn't hear the end of it. So let's keep moving on here. Now for the last, so this video has been 7 minutes long. For these last 7 minutes, because I have to cap it at 15, we're going to solve. This is going to be a bulk of your quiz, is solving. So let's talk about it. Here are my hints. And I know this isn't everything, but in 7 minutes, these are the meat and potatoes. If you see a problem like 14 or 15, those are exponential equations. How do I know? Because there's not a logarithm in there, right? It's the x is up there as the exponent. So those are exponential. There are 2 ways to solve exponential equations. Okay? There are 2 ways to solve exponential equations. There's 2 ways. We'll put one here and one there. First way is to get the same base if you can. And then the second way is to use logs. So for these, we're going to get the same base. What do I mean by same base? I can only do one of these, so I'm going to do 15. You can do 14. I see that 1/2 and 8. I know those are different numbers, but those can both be written as 2 to the something power. 8 is probably the easiest to see. That's just 2 to the third power. So we'll just go ahead and leave that over there. But 1/2, that's 2 to the -1 power. Don't believe me? Type it in your calculator. 2 to the -1, it'll give you 0.5. So what I did is I just rewrote 1/2 as 2 to the -1, and then I'm going to still have my other exponent that was there. We now officially turn this to the same base. We can now, to solve for x, just look at the exponents. If you can ever get it to the same base, then you can just literally solve from there, right? Booyah, -7. So go ahead and try that with number 14. Okay, I got to move on to ones that don't move the same base. I'm going to stay with exponentials. Let me find an exponential that you can't solve using the same base method. It's not there, and you're going to want one for the quiz, so I'm just going to make one up. What if I had 2 to the x plus 2 equals 15? You can't get those to be the same base. So what do? We use logarithms. So I'm going to just say the log of this side. I'm going to say the log of that side. And what is the whole point of doing that? It's because now we can use the power rule and we can take this exponent and move it down front. The whole issue with solving these was that the x is up there and we can't do anything with that, right? So by putting log to both sides, notice I did it to both sides, this x can go down front and we're left with x plus 2 times the log of 2 equals the log of 15. And now I'm just solving for x. I have this times this. So I need to divide both sides by log of 2 to get that to cancel. And so I'm left with x plus 2 over here equals log of 15 divided by log of 2. You can't change that to log of 7.5. Logs don't divide like that. So then last step to get x by itself is subtract 2. So our final answer is log 15 over log 2 minus 2. Boom. Bada boom, bada bing. So that is how you would solve an exponential equation that you couldn't get same base on. You have to use logs, okay? Now, to finish up our time, I want to show you how to solve log equations. Here's how you solve a level 1. Here's how you solve a level 1. You convert it to exponential form. You do the around the world thing. So x to the 1/5 power equals 25. So what is x? Well, now we got to bust out our algebra rules. How do we get rid of that 1/5? What the heck, Smith? I don't know how to do that. You do. It's just been a while. You raise it to the 5. That would cancel, and you'd just be left with x. But what you do to one side, you have to do to the other. So your answer is whatever 25 to the 5th is. That's a big old number, so I'm fine with you just leaving it, 25 to the 5th. But I hope you noticed that around the world piece. And when you see a natural log, you got to remember this or you will be screwed. There's a base of e that's invisible there. So it's e to the -4 equals x. You make your around the world, okay? Final problem on this video will be this one. Because if you can do this one, I think you'll be able to do most of them. How do we solve a logarithm equation that has multiple logs? I can't go around the world with multiple logs because what do? What if we combined these using the product rule? Then we're down to 1 log, right? Log base 9 of 2x minus 3 plus log base 9 of 3x minus 1 would be log base 9 of whatever 2x minus 3 times 3x minus 1 is. What would that be? Gotta do a little FOIL action. 2x minus 3. You guys are seeing me struggle. It's late. It's 10:30 at night. I love you guys. I'm making this video for you at 10:30 at night. What is that? That's 6x squared minus 2x minus 9x minus 11x plus 3. So 6x squared minus 11x plus 3. I'm down to 2 minutes. Yikes. I'm on the clock. Equals 1/2. Now that we have it as 1 logarithm, check what we can do. Around the world, baby. 9 to the 1/2 equals all of this. What do you mean, Smith? I mean this. 9 to the 1/2. What is 9 to the 1/2? That's 3. So let me save myself some space. 3 equals 6x squared minus 11x plus 3. How would you solve this? You subtract 3 from both sides, and you have 0 equals 6x squared minus 11x. And I hope you know how to solve that because we've been doing it all year. Pull out the x. Set it equal to 0. There's one answer. There's your other answer. Okay? So yes, you mean we still have to factor on some of these, Smith? Yeah, you might. But the key is to know how to use your log properties to get to that point. I hope this was helpful. And finally, I'm going to give you something that I'm not going to give 5th period. I know you saw Desmos and you freaked out, but I just want to remind you. If you do like 2 to the x power, it looks like this. If you did log, will it let me do to the base? I don't know if it'll let me do that. Let's just do log of x. I just want to remind you, I know this isn't perfect. Well, I know how to make it perfect. But my time's running out. Yeah, let's do it. E to the x and natural log of x. Just a reminder that these are inverses and that you can switch up their x and y's. That's your final hint. Just trust me. That's going to come in handy. If you made it to the end of this video, you are welcome. Good luck. Text me if you need me, 615-319-5440.